the last part. What is the countermeasure? So we see so far the best countermeasure for this technique or any return style technique is the position independent executable. With the position independent executable, every address are randomized, even the code of the program itself. So you cannot return to it because it's randomized. It's also at the 0 byte, the null byte stack of address. So it will be hard if the ASCII-Armor enable or the null byte is dropped at the input. So far, the position independent executable is the most effective countermeasure to block return style exploits, but it's not widely adopted by vendor. You can see a lot of application is not compiled with the PIE option because it requires the recompilation. And some application may impact with the performance penalty. So it's currently used in most critical application in popular distribution. In summary, so what we have seen here, generic, reliable, and practical return-oriented exploitation technique that can completely bypass on the system-level protection on modern Linux 32 bits can bypass and ASLR ASCII-Armor, and it does not rely or does not need the help from all the information leak bug, and it can work on most of the binary. So buffer overflow now can be exploited on Linux, and we have solved that the automated tool can be built to generate the ROP payload. It can be easy. So this technique, we did not research more on other operating system, but I think that it can be extended for other operating system like Windows, Mac OS, or BSD, because the x86 programming model is similar. Thank you for listening. I'm done. Thank you. Now, you have any question?
So, this whole technique relies firmly on the fact that your gadgets are at a null location. That's not randomized.
You mean that this technique will rely on the binary location, not randomized? Yeah, exactly. With the binary combined without the PIE option. Yeah, that is the most popular on distribution. Yeah, exactly. With return style exploit, you need something static to return into. Thank you.
And you're releasing your Python script?
Yes, Python. Yeah. Sir?
Unless I'm way off base, it also required that your script be executed as an application that was residing on the machine. You press it from outside.
Mm-hmm. So your question is how to attack from outside, not on the local machine. Yeah. In our demo, we run on the local, but actually we can generate the payload. No need to execute the vulnerable. We just generate the payload and send it to the remote host. All right. Yeah.
So you mentioned that you resolve the address limits on
Exactly. With the return-to-libc style exploit, it must rely on the libc version. Yeah, so if you have to generate the exploit for destination, so you have to know what libc version. Yeah, you can pull the libc from the remote host, put on your host, and generate the payload, generate the payload, and send to the host. Yeah, thank you. Mm-hmm. So I'm sorry, I cannot catch your question. You can repeat it?
You're changing the data section of the executable.
Mm-hmm.
In particular, the DSS. So it's expected that certain counters or syntaxes will go wrong because the executable. So is the executable flashing after you have it? So can you keep it running?
Actually, two keyboard I got it. So you mean that if we write to the data session or BSS session, it will make our the destination program crash after the exploit. Two keyboard first. If we exploit, we want to, for example, get a cell and forget the rest. It's okay. And if we want to return back to the function silently, so we have to carefully choose the address. We can pick any uninitialized, unused data area. It's available because the data is large enough for your shell code. Yeah. Thank you. Yeah, interesting question. How about the 64-bit platform? The 64-bit platform, the idea can be applied except one. In the 64-bit platform, there are lots of NULL byte in the address. So if our input drop at NULL byte, forget it. If we can input the NULL byte in the input, there another thing to be considered. That is the programming model on 64-bit is different. Argument of function is not on the stack, but it loads into the register. So you have to find the gadget that load the argument address to the register. But it can be applied. I had a demo exploit for libc proxy. It's something out in 2009, and it worked on the 64-bit. Thank you. Anyone else? Okay, thank you very much